Okay. See now in geography, in your prelims, if you take only prelims, the number of questions from geography, it comes around 20 plus out of 100. Okay. This we are repeatedly telling it every year. If you see that last 5-year question, number of questions what they are asking in general studies prelims, almost 20 plus questions are coming from geography alone. Now this entire geography, what are the areas you need to study for the preliminary general studies? Okay, there are two sections you have to study. One is physical geography. It consists of 5 chapters, that is geomorphology, climatology, and oceanography, and biogeography and environmental geography. These are the 5 chapters that consist of physical geography. And the second major heading is, that is Indian geography. Okay, so these 20 questions, sir, from where and all the questions will come? If you pinpoint, from physical geography, half of the questions will come, particularly from these 3 chapters. Geomorphology, climatology, and oceanography. These 3 chapters are very important. From there, almost half of the questions will come. And the remaining Indian geography, you need to study thoroughly from NCERT as well as from the institute material, plus from the class notes. Here you will get the another half of the questions. So overall, you need to cover these 2 sections, physical geography and Indian geography. Okay. Now, when you go for a preparation, this physical geography, it is related with principles of geography. It is otherwise called principles. Here we are going to study about the concepts. As I have already told in the last class, geography is completely a concept-oriented subject. Okay, you don't need to mug up anything. If your concept is very clear, you can able to easily answer the question. Okay, you don't need to memorize also anything in this. It is not like a history or other subjects. Okay, where it is fact-oriented. Here it is completely concept-oriented. So those concepts are, we are going to study in detail about physical geography. You have to study this section first when you go for a geography. It is not like you can go for the Indian geography, then you can come back. So your understanding will be different. So first you have to finish physical geography so that your understanding and concepts will be very clear. Then you can go for a Indian geography. Am I clear? So that is how I have decided the entire design of the course. So now we are going to start with the physical geography. In a physical geography, the very first chapter is geomorphology. Am I clear so far about the entire subject line? What are the subjects are there in your geography?
Yes.
Okay. So here you please note down these 3 chapters are you need to study for prelims under physical geography. This is very important. Once if you have completed this, if you go to the Indian geography, your understanding will be much more better. You can able to easily apply the logic. It is a completely logical subjects, and you can able to come to the conclusion or the answers. It is clear. So let me start with geomorphology. Here, geomorphology means what? Any meaning? Anybody? Geomorphology. Geo means earth.
Yes. Study of landforms and land evaluations.
Exactly. So the morphology means how the structures are evolved. The earth structures. Earth structures means like a mountain or a river, a different type of rock or a soil. Okay, all those structures, ocean surfaces. Okay, all the earthly structures, how it is evolved. What is the process behind it? So that is the study about geomorphology. Okay. Whereas the second chapter, climatology, means completely study about the atmosphere. Above the earth, we have a huge atmosphere. And what is the characteristic features about the atmosphere? That we are going to study here. That is about the climatology. Oceanography, it is completely about the oceans. The earth is covered by 2/3 of the area under water. So the ocean surfaces, how they behave, okay, how they react with the human being. That we are going to study here. So one for a land, one for atmosphere, that is air, another one for water. So these are the 3 chapters. Okay. Sir, what about these 2 chapters? That is biogeography and environmental geography. That is also you're going to study, but separately under environmental issues. So you have a separate topic or subjects in your prelim syllabus that is called environmental issues, Under that, you are going to study about biogeography and environmental geography. So when it comes to the geography, you stick to these three chapters, that is geomorphology, climatology, and oceanography under physical geography, and Indian geography is separate. It's clear. So any doubts so far?
No.
Okay, so now we will start geomorphology one by one. So geomorphology, first you need to know, as I told, what do you call, the earth structures, how it is evolved. Okay. Before going into that, before coming to this geological time scale and this life cycle, you need to know about the solar system. So first we'll go about the universe and solar system. Then we land on the earth. There we can go for the geological scales, the time scale and everything, so that it will be in a proper order. Okay. The solar system, what you see here, the entire world is doing a lot of research. About few planets. So here, what is the whole idea behind why the human being want to explore the universe, want to explore the outer space? What is the whole purpose behind it? Anybody? What they are trying to achieve it, or what they want to do? Say, for example, ISRO is doing a lot of projects, and what do you say? NASA is doing a lot of projects. So many countries are coming up with a lot of ideas, and there is a keep what do you call it, poking their nose into the outer space and the universe, try to identify something. So what is the total objective of these people? So what you see, this is universe, not exactly universe, it is a Milky Way Galaxy. Okay, so this is the Milky Way Galaxy, like this, it keeps circle inside. Okay, in this, the remote end, say for example, approximately I'm putting a dot, this dot and covered by this particular structure, this is nothing but our solar system. You got the point? So this is the Milky Way Galaxy, and whatever the dots you are seeing it here, all these things are other galaxies. There is a millions of billions of galaxies are there. One of the galaxy is Milky Way Galaxy. Okay, so universe is so big, unimaginably big. So out of this Milky Way Galaxy, you have again millions of billions of stars in solar system. Okay, you can't even count that many stars and solar systems are exist only in Milky Way Galaxy alone. In that Milky Way Galaxy, we have our own one solar system, that is our sun and 9 planets. That is what you are seeing here. Okay, this is our family, that is the solar system, solar family. So this is sun, followed by 9 planets, whatever we have studied in our school days. Now we are talking about 8 planets. It is clear. So now you just imagine it. This is the order: Mercury, Venus, and Earth. We are here. We are here. This is Moon. And Mars. And Mars. Now, the entire humanity, if you see that ISRO is talking about the Moon, NASA was talking about the Moon, or we are thinking about the Mars. So our major interest for the entire human being is either Moon or Mars. Okay. We don't bother about Venus and Mercury. Why? Or we don't bother about much of Jupiter or Saturn. Why we are not doing it?
They are far comparatively.
Yeah.
Life cannot survive over there, sir.
Why? Whether the
Because
Mars can survive?
Distance.
Distance, okay. Apart from that,
Mars and Moon are having a similarity of Earth somehow, and distance also it is quite.
Okay.
Oh.
Any other reason? Any other reason?
Venus and Mercury are nearer to Sun, sir, because of the temperature. I don't think humans can survive there.
Exactly. So that is one of the major reason why we are not considering too much on these two. Okay. So here you need to understand, even we are doing some remote research about Venus and Mercury, even ISRO is doing it, but we are not so much focused and obsessed on these two planets. Why? Because the average temperature. So before going into that, what is the average temperature of the Earth where we are living? Average temperature means you should consider all the places of the Earth taken as the entire Earth as a planet. What is the average temperature? Any idea? What is the average temperature of the Earth?
13 degrees Celsius, sir, nearly.
Which one?
13 degrees Celsius.
Okay, you are almost close. It is 14 degrees Celsius. The average temperature of the Earth is your any given place. Suppose, for example, if you check for Bangalore, it might be around 26, 27 degrees Celsius. Okay, as of today. So that is not the average. Okay, so you need to take the entire India average as well as the entire Earth average. So when you consider even North Pole or South Pole, and the 2/3 of the areas are water, all those surface areas are considered, the average temperature of the Earth is around 14 degrees Celsius. Okay, in this minimum, in this 14 degrees Celsius, minimum temperature, it goes how much? Anybody? On the Earth, when I have a 14 degrees Celsius, I want to know what is the two extremes of the temperature, minimum and maximum in the Earth, where the human is living. Where human being or villages or some settlements are there, what is the minimum temperature in which the human is living as of today, and maximum temperature? Anyone? Simply apply, nothing harm. Simply apply your logic. It is completely logical subjects. Where minimum temperature recorded in Earth, where maximum temperature recorded in Earth. The minimum temperature is around minus 45 degrees Celsius. I'm talking about where human settlement is there. If you go to the North Pole, it might be further minus 80. Antarctica, North Pole are minus 80. There, the human beings are not regularly living. Once in a while, we go in a summer month. That is not the case. Minus 45, it comes under the some villages in Russia. It is called Vladivostok. Okay, you can check it in Google. It is a small village in Russia. It is called Vladivostok. There, the minus 45 degrees Celsius is recorded, where there is a village. The people are ordinarily living there. It is so throughout the year, the people you can see there. Okay, and the maximum temperature recorded at Libya in Sahara Desert, it goes around 56 degrees Celsius. This is plus, this is minus. Okay, when I told average temperature of the Earth is 14 degrees Celsius, but the two extremes of temperature, how much it goes? Almost around 100-degree difference. Almost around 100-degree difference. It is clear. Whereas if you take Mercury and Venus, their average temperature alone, it goes around 400 plus degree Celsius. So just imagine it, 400 plus degrees Celsius. Whereas if you take Earth, this maximum temperature, how long we can survive? Suppose right now it is 56. How far, if the temperature increases, the human being can survive on Earth? Any idea? Suppose tomorrow the temperature becomes 60 or 70 or 80. Can we able to survive? That's my question. With a normal manner, the way we are living right now, with a normal, simple cotton dress, not with a specialized shoot. You know, what is the leverage? What is the, what do you call, space we have? Above 60, probably we can't live. maybe you should always be inside the air conditioned room. You can't roam around. Above 60, it's very, very difficult. 60, 65, you have to vacate because your skin will start bleeding or ulcer may happen. 70, bleeding will start. 80, the human being start meltdown. You got the point. At the degree of around 80 to 85 or 100 degrees Celsius, you just imagine it, human bodies start meltdown. We are completely, what do you call, meltdown due to the huge amount of temperature. Minus temperature, of course, you know that even minus 45, it's very, very difficult. Some of the people are surviving there. Less than that, it's very, very difficult. So we are not living anywhere in Antarctica or Arctic throughout the year. Okay, whenever there is a summer, whenever the temperature comes around 10 or 20 degrees Celsius, there is a minus. During that time, only the people used to hit that particular location. Okay, so the minimum temperature where the human being is living, somehow with some technique, that is minus 45 degrees Celsius, maximum is 56. So far, it is recorded. The recorded place was Addis Ababa. Addis Ababa in Libya. It's clear. So this is the range of temperature where we can survive. You got the point. Range of temperature means it is a minimum and maximum. The difference between minimum and maximum. Okay, only in which the human being can survive. Whereas if you take Mercury and Venus, here the temperature is average temperature itself 400 plus degree. It's very, very huge. It's unimaginable. That means human being cannot survive. Even if you go and do research, even if you are doing what you call a lot of activities, it's very, very, very difficult. A lot of technological inputs, even if you apply, it's unimaginable to survive there. So there is no point in doing too much of research like what we are doing at Moon or Mars. That is why international space agencies are never focus much on Mercury and Venus. Our focus area got shifted to Moon as well as the Mars. And whereas these two, it is to an extent, the average temperatures are within our bracket, and the size of the planets also it's within our bracket. And we need some conducive atmosphere that looks like, okay, these planets can be in future, we can occupy, we can survive. With a slight modification of our lifestyle, we can able to occupy and survive on Moon and Mars. So with that help only, a lot of international space agencies are working completely on this. Am I clear? After Mars, if you see that we have an asteroid belt. So what is the meaning of it? This belt. What does it mean? Any idea?
Surrounded by asteroids, sir.
No, asteroid means what? How it happened? How it happened? Asteroid means how it happened. See, for that you need to understand about Big Bang theory. So Big Bang theory, it is mostly widely accepted hypothesis. Hypothesis means what? Anyone? What do you mean by hypothesis? Hypothesis means it is an unproven theory. Unproven theory, but widely accepted. But widely accepted. So what the Big Bang theory says, it deals about origin of the universe. Origin of universe. That means for a question how the universe was origin, okay, for that Big Bang theory is giving an answer in such a manner. There was one gigantic star. Due to some unknown reason, those gigantic stars are got exploded. Why it got exploded, nobody knows. How that gigantic star emerged, nobody knows. It was not answered by the theory. And it got exploded. The exploded fragments, they came out from the giant star with a particular momentum, with a particular angular momentum. With that momentum, each and every objects are keep roaming around something else. This is the concept what they're given. Suppose, say, for example, in a moving bus, suppose if you are coming out of the bus, what we do? We used to run for a while. We used to run for a while along the direction of the bus. Why we are running it? Anybody? Anyone? Most of you might have done. in your school days, I mean college days, when the bus is running, before stopping itself, we try to jump off and we used to run along with the bus direction, and then we'll put a brake and come back. Why? Because based on basic Newton's theory, nothing is at rest. Everything is on movement. Why everything is on movement? Right now, say for example, you and me sitting and talking it. Do you think that we are at rest? Do you think that you are peacefully sitting at home? Tell me. Or you are on travel?
We are at rest.
Huh?
We are at rest.
No, sir.
Yeah.
We are in the rotation of the Earth.
Exactly. See, we are on rotation of the earth. Keep it in your mind. We are on sitting on top of the earth, and the earth is moving. Earth is moving at the speed of 27 kilometers per minute. Keep it in your mind. Such a massive speed that is rotating on its own. And we are also traveling at the speed of 27 kilometers per minute. That is the actual meaning. How, when the bus is traveling around 60 kilometers speed, all the passengers, those are sitting inside also, they are traveling at 60 kilometers speed. That is why when the moving bus, when we are coming out of it, we are in the same momentum, we are forced to run along with the bus direction, because the same speed we are coming out. Suppose the bus is slowed down around 10 kilometer speed. When a person is coming out of it, he is also coming out at around 10 kilometer speed. So he cannot put a brake immediately. He is not at a rest, even though he was sitting comfortably inside the bus. Keep it in your mind. So when he is coming out, he is also in the particular momentum of speed of the bus. Now the same logic you have to apply here. When a giant star got exploded, whatever the fragments they came out of it, they came out with a particular momentum in which the giant star got exploded. And each and every fragments which is exploded out from the giant star, they started moving around that particular mid position in the same momentum, because they got exploded with an angular momentum like this. Angular momentum. This is the concept explained by the Big Bang theory. It is clear. So in the universe, what is happening is each and every object revolving around something else. Okay, even what the scientists are claiming it, even the Milky Way Galaxy is roaming around something else in the middle of the universe. We don't know what is it. We literally don't know what is it, because Milky Way Galaxy also, it is not static. Keep it in your mind. This entire galaxy is also on movement. Each and every solar system is on movement. Each and every planets are movement. Moving on something else. Moving on something else. So this is the theory given by the Big Bang theory, but Big Bang theory is a hypothesis because nothing is proven. So we call them as a hypothesis. It's clear. So when these objects are coming out of a giant star, when they are keep revolving around something else, how long they'll go for the rotation? How long they can go for the revolving? You take this image. Suppose, say for example, you are coming out of the bus, how long you are keep running? You are keep running for a while, then with the physical effort, we are putting a brake. Then turn around, because we need to move in opposite direction. Okay. Whereas here in the planets, when the planets are expelled from the giant star, when they are coming out with the angular momentum, they are also losing their momentum over a period of time. Okay. So each and every planets are having some lifespan. So when these angular momentums are hitting the zero, again these planets are going for the explosion. Each and every objects. Say for example, you have a sun. Sun is on movement on a particular direction. And after some time, sun is also having the lifespan. When their momentums are come to an end, sun will reach and it become a black hole. Okay, what will happen to these planets? What will happen to the Earth? Earth also will lose its momentum. On fine day, will go for the explosion. When it is getting exploded, it become like a too many fragments like asteroid. So the asteroid belts are nothing but once upon a time there was a planet next to Mars. That planet lifespan come to an end and it got exploded. Now the exploded fragments are keep moving in a particular angular momentum in and around Sun. You got the point? That is called asteroid. You got the point? Luckily, these planets are yet to go for the explosion. Okay, so that is what we say. Each and every celestial bodies are having a lifespan, like how you and me have a lifespan. We are not immortal. Same way, these planets also not an immortal. Okay, if that is the case, what is the age of the Earth? What is the lifespan of the Earth? How long it's going to survive? So approximately they have calculated it is around 5 lakh crore years. This is the total lifespan of the Earth. Sir, that if that is the case, what is the age of the Earth right now? Age of the Earth is 4.5 lakh crore years. You got the point? So don't get panic. We have another 50,000 crore year, approximately. I'm giving just approximate figure. These figures will be plus or minus changes when you go to the book or when you study from the net. But the whole concept is revolving around it. You just pick up the concept. You got the point. That means majority of the Earth's lifespan is already over. We are in another 50,000 crore years. Don't worry about it. You and me, we are just living in a fraction of a second when it comes to the celestial body. Nothing much. It is clear. So after that, Earth also maybe get fragmented like this. Earth also maybe get fragmented like asteroid. That is the meaning of asteroid. You got the point. Now next to asteroid, we have a Jupiter. What is the structure of Jupiter? It is otherwise called? It is otherwise called what?
Gas planets.
It is a gaseous planet. You're correct. Okay, so the planets are emerging like this. Gaseous planets means what? This planet, it is in making, you understand. Earth also initially, in the initial stage of the formation, might be under gaseous planet. Keep it in your mind. And these gaseous planets are synthesized and contracted, and it became a solid planet. Then it started giving life system. Okay, one by one, like amoeba, single cell, multi-cell, and multiple fragmented animals. All those things are, it is starting. The process of planet in making is the first stage will be the gaseous planet. So Jupiter is in the form of making, understand? Okay, whereas Earth, much more senior to the Jupiter. Once upon a time, it was a gaseous planet. Later, it becomes solid. Later, water is emerged. Then the single cell animals are emerged. Multi-cell animals are emerged. Gradually, the matured life system, that is human beings, are emerged, and we are studying about the other planets. That is why we have lost almost 70 to 80 or 90% of the entire age of the Earth. It took almost these many years to reach this particular stage. Am I clear? So here, if you see that from the Earth, when we are watching this entire planet, our solar system itself, it's very, very huge. If you see our solar system itself from here to here, the space is very huge. And we have sent one Mars mission from ISRO, we have launched. Can anybody say how long it took to reach Mars? How long, what was the journey period? Just try approximately. After our launch, how long it took to reach Mars? We just went up to the Mars and taken a photograph. We went to the moon, we landed. Our robotic devices were landed, but it was not a proper landing. Mars, we went up to the atmosphere of the Mars. We haven't landed. We just taken a photograph, images. From the Earth to reach Mars, it took almost 1 year, exactly 1 year. In the modern era, we are talking about 21st century or 22nd century, whatever it is, in the modern era, with the rocket science. For you and me, the rocket might be much more faster on Earth. But when it comes to the outer space, it is like a baby step. It is like a baby step. You understand? From the Earth, in the year 2000, what do you call it? European Union, they have launched a mission for Saturn, for this planet. Saturn is having 2 moons. Can anybody can say the name? Name of the moon of Saturn? Like how we have a moon. Same way Saturn also having a moon. What is the name of it? Saturn is having 2.
One is Titan, sir.
One is Titan, another one is Phobos. Okay, so this European Union from the Earth, they have launched a mission for Titan. And this the device it went to the what do you call Saturn, reached after how many years, you know? After 18 years. 2000 they have launched, 2018 they have reached. I'm talking about one-way journey. Within our solar system, halfway through, we have to reach Pluto and Neptune. Am I clear? See the distance. The distance is what you call unimaginable. And the speed in which what we are traveling, it's very, very slow. We don't know what to do. We don't know which vehicle to board, which method to travel in outer space. So there is a lot of research it's going on. Are we missing something? Because the scientists are asking a question like this. Are we missing something in terms of communicating with the outer space? You got the point. That is how the research is going on. So right now, what kind of research they are doing it? Anybody? Why we are sending this, say for example, Saturn, Titan, Phobos, Moon or Mars? Why we are keep focusing on this outer planet? Any idea? Any idea? As I told, the primary reason was occupying outer space. Occupying outer space. Okay. And the second reason is there any aliens? Is there any aliens outside? Because if you think we are alone in this entire universe, we can say we are the number 1 fools. We are the number 1 fools. Okay, who is the famous scientist next to Einstein? Recently, who got expired? Stephen Hawking. Stephen Hawking. He was considered as a best scientist, astrophysicist next to Einstein. Recently, he died. He has written a book called Brief History of Time. This question was asked in your exam. Brief History of Time. He has done a complete research about black hole. That is, what will happen to the sun once they reach their lifespan. How the transformation of sun, the star, it become a black hole. That was the research area where he worked upon. He is clearly saying it. Of course, there are aliens. There is no doubt. Of course, there are aliens. There is no doubt. You don't need to have a single percentage of doubt whether they exist in the universe. 100% they are exist. Better not to disturb them. This is another statement given by him. Better not to disturb them. Why? Why? Because what he is claiming it, the aliens may not treat the human being as a well-established, developed creatures. They may treat you like a virus and bacteria. That is it. For them, we are all virus and bacteria. Keep it in your mind. This is I'm not telling. The famous astrophysicist Stephen Hawking has told in his book Brief History of Time. Am I clear? So there are aliens. Scientists have already told not to disturb them. But what to do? We need to communicate with them at least to get some advanced technology. Because what we have, the technology on the Earth, it looks very, very primitive. It's like a baby step because it took years together to reach or to jump out of our own solar system. To reach here, it takes years together. Just to escape out of solar system itself, it takes years together. So right now, the kind of research what we are doing is, it is completely about how to communicate with aliens. So what are the steps we are doing it right now? Are there any project is going on related with this? Anybody? Okay. See, right now, what is the project is going on means sending sound waves or signals from the Earth to outer space. That is already started. Even India is working on it. Chinese are working. America is working. A lot of countries are doing it, particularly US, China, and even India. Okay, so the sending sound waves, what do you call, in a particular speed and wavelength, focusing on outer space, the entire Milky Way Galaxy or whatever it is. And the sound waves are, what do you call, with a communication code or something, they are sending it. And they are waiting for reply from the other end. If somebody is there outside, definitely they'll get back and then reply it. It is clear. So what is the outcome so far? What was the outcome? The outcome is, recently they have got to the conclusion, they have got the reply sound also from somewhere else from the outside. Keep it in your mind. So reply wave also they have got. But we don't know what to do with that wave. That's the reality. We just received some sound waves the way what we have delivered. More or less, looks like. And it has come from somewhere in some other galaxy. Billions of light years away. Took so many years to receive. And they've reached Earth. Scientists have collected it. But they don't know what to do next. That is the condition right now. So if you have any logic, you have some idea about how to communicate with the outside aliens, very well you can able to contribute, because there is a huge amount of space, huge amount of knowledge is required in this particular area. Am I clear? So any doubts so far in this? So on the examination point of view, you need to know very, very limited missions, what Earth is doing, I mean, what ISR is doing, what NASA is doing, what the other major international agencies are doing about Moon and the Mars. If you know, that is highly enough when it comes to the questions related with your science and tech or related with the universal solar system. Am I clear? Because what we know about the universal solar system, it's hard even 1%. 99% is empty. Am I clear? Probably might have understood based on where we are standing. It is clear. So these things are identified by the scientists, what do you call, as a target-oriented planets just outside our solar system, which looks more or less like Earth. These are all next to Mars. Probably the humanity may try to reach these particular places. See, for example, this planet you see, it looks like almost like Earth. Almost like Earth. Okay, and then you can see the planet radius. I mean, we can see the planet radius, planet mass, planet density, surface gravity. See, our surface gravity is 1. This planet surface gravity is 0.48 g. That means almost half of it. It's manageable. 0.93, gravities almost look similar. 0.85, gravities look similar. 0.87, gravity looks similar. So these kind of planets, we are taking it. We are taking it. It is clear. But these planets are orbital period, you see. Here it takes 365 days per year. Here the orbital period is just 10 days, 12 days, 6 days, 4 days, 2.42 days. You got the point. These are the planets are identified just next to our solar system. Just next to our solar system. It is clear. So whereas if you take Earth and the Mars, you just compare it. Our 1 year is 365, here it is almost double. Okay, distance to star, it is far away from the star. Planet radius, not so huge difference, almost 50%, half of it. Planet mass, again 110. Planet density, more or less similar, nearby. Surface gravity, again almost what you call 1/3. Okay, but even though there is a lot of difference, which is just next to us, so we are showing more interest on the Mars. Am I clear? And these planets also, it is giving us a lot of hope for a future research. Am I clear? So these things and all I have collected from the International Astronomical Union website. It is clear. You can go back and check it. The same data will be available. These are the future-oriented planets where we are going to target. So they have clearly mentioned next to Mars. What that means? They'll pick up one by one B, C, D, E, F, G. They'll try to target. It is clear. Probably we don't know. These planets might be some other human-like creatures might be exist right now, because you see this planet almost looks like Earth. Almost looks like Earth. Only the gravity and other stuffs are slightly differ. Okay. Otherwise, it looks like they have water also by simple logic. This color combination, other stuff. This is also. Okay. So these planets are in the hopeful list of next expedition. This will come back. This is the star, I mean the sun. Here you can see the comparison. Here you can see the comparison. So this is VR, this is Earth. This is Earth. You live here. This is the size of the Earth and the sun. You just compare it. These are the other planets of our own solar system in terms of size. In this such a many creatures, we have India and we have Bangalore. We are sitting somewhere and talking about Milky Way Galaxy. And do you think that nobody else is there? Tell me, what is your opinion about aliens and outer space and other planets and other creatures? What is your opinion? 200% it looks like there are a lot of people outside, but really we don't know how to communicate with them. It is clear. Am I clear? So far, any doubt in this about universal solar system? Any doubt?
No, sir.
Fine. So there is a lot of space for the research. This particular chapter don't go for a deeper study, because once if you started taking this particular chapter as a deeper study, you may not study for the rest of IAS, because there is a huge interesting area to study here. Okay. Whatever we discussed so far, that is highly enough to answer the question for your prelims, because the area is very, very limited even for the agencies. Okay, they don't know what to do other than that going to Moon and the Mars. And the amount of question expected from here also it's very, very limited, because most of the research are in the initial stage of the hypothesis level. It is clear. So next, now so far we have discussed about the universe and solar system. Next, we'll see about the relationship between the sun and our own moon and the earth. Okay, in terms of something called solar eclipse, in terms of something called lunar eclipse, or new moon day, full moon day, how all these things are happening, those things and all, we can discuss it in the next class. Okay, our next topic will be on these areas.